A NASA spacecraft is set to make history today, getting closer to the sun than any other human-made object.
Imagine this: humanity is about to do something that was once thought impossible. We're not just sending a probe into space, we're sending it closer to the sun than ever before, daring to get closer to the heart of our solar system. It's happening right now. This is not science fiction. This is real. Welcome to Space Theory, where we're about to take you on an incredible journey to the edge of the solar system and beyond.
Our sun in all its fiery splendor. We've been studying it for centuries, but there's still so much we don't know about it.
Meet the Parker Solar Probe, a spacecraft that's rewriting the rules of what we thought was possible. This tiny, fearless probe is about to achieve something that no human-made object has ever done. It's flying closer to the sun than Mercury itself. So why is this mission such a big deal? Solar storms? Those come from the sun. The auroras? Yep, those are linked to the sun's activity too. Our modern world literally revolves around the energy the sun provides. But for all we know, we've barely scratched the surface. The sun still holds countless mysteries. How does it heat its outer atmosphere to millions of degrees, even though its surface is much cooler?
This material forms the sun's atmosphere, the corona.
What drives solar wind, and how does it impact Earth's magnetic field?
It accelerates up to millions of miles per hour out of the corona, and we don't know how.
How can we predict solar flares and coronal mass ejections events that can disrupt satellite communications and even power grids on Earth? These questions have baffled scientists for decades, and the Parker Solar Probe is here to change that. Imagine the level of technological innovation it took to send a spacecraft this close to the sun. For years, humanity tried and failed to get close enough to study its mysteries up close. But now, thanks to the Parker Solar Probe, we've finally done it. Launched by NASA in 2018, this spacecraft is designed to withstand unimaginable heat up to 500 deg 1, 377 deg Z, thanks to its cutting-edge heat shields, made of carbon composite material. The shield is so effective that it keeps the probe's instruments at a cool 85 deg 29 deg, even though the outside temperature is scorching hot. And if you think getting close to the sun is a straightforward mission, think again. It's like a cosmic game of catch me if you can. Each time it flies around Venus, it uses the planet's gravity to alter its trajectory and slow itself down, which allows it to get closer to the sun. The probe's orbit is not a simple one. It takes years for it to complete a single loop, and each pass brings it closer to its ultimate goal, flying within 3.83 million miles of the sun's surface. Now, here's where things get mind-blowing.
All of these brutal conditions. It's a tough little spacecraft.
This mission is breaking records. Parker Solar Probe hurtles past the sun at 430,000 miles an hour. It's the equivalent of flying from London to New York in less than 30 seconds.
And right now it's breaking records, becoming the closest any spacecraft has ever been to the sun. It's less than 4 million miles away. Keep in mind, that's less than 1/10 the distance between the sun and Mercury. In fact, the probe is on track to break its own records over and over again as it nears its perihelion, the point in its orbit closest to the sun.
It's extraordinary what this probe has to survive. We're talking temperatures of well over 1,000 degrees. It is being blasted by radiation from the sun.
This is not just impressive, it's groundbreaking, reshaping our understanding of what's possible in space exploration. So, what exactly are scientists hoping to learn from this daring mission? The sun's corona has long been a mystery to scientists. Despite being cooler than the sun's outer layers, the corona reaches temperatures of 2 to 3 million degrees Fahrenheit. One of the key questions is, how does a corona get so hot? It defies our basic understanding of physics.
The Parker Solar Probe must survive the radiation and extreme temperatures it will encounter to solve some of the mysteries about our star.
The spacecraft is also investigating solar wind and its interactions with Earth's magnetic field. Solar wind can have dramatic effects on our planet. It can cause geomagnetic storms, triggering auroras, but also disrupting satellites and even electrical grids. By understanding solar wind more precisely, we can better predict space weather events and protect technology that modern society relies on. Additionally, scientists are studying solar magnetic fields. The sun's magnetic fields are responsible for solar phenomena such as sunspots, solar flares, and coronal mass ejection CMEs, all of which can impact Earth's space environment. The Parker Solar Probe is helping to map these magnetic fields in detail for the first time, providing crucial data to understand solar activities and their effects on Earth and beyond. But don't think it's all smooth sailing. The Parker Solar Probe is facing extreme radiation, blistering temperatures, and a host of other challenges. Every moment the spacecraft is exposed to the intense heat and radiation of the sun. The engineering teams on Earth are carefully monitoring its systems, adjusting parameters in real time to ensure the spacecraft can survive. One of the most critical components is its heat shield. Even at its closest approach, the probe is still protected by the shield, which prevents it from getting destroyed by the sun's intense heat. The spacecraft's instruments are constantly being calibrated and shielded from radiation, making it a highly sophisticated operation. This real-time adaptability has never been done before in space exploration. This is truly a mission of survival, resilience, and cutting-edge technology. The data coming back from this mission is nothing short of revolutionary. Not only will it help us understand the sun in unprecedented detail, but it will also provide crucial insights for the future space exploration. Think about it, understanding solar phenomena is essential for protecting astronauts on deep space missions, improving satellite technologies, and even unraveling the secrets of distant stars and planets. The Parker Solar Probe's findings could be the key to unlocking many long-held questions about the behavior of stars, magnetic fields, and plasma physics. For instance, could understanding the sun's dynamics provide insights into the formation of other stars in distant solar systems? How might the sun's activity affect the habitability of other planets? Just imagine the possibilities. This knowledge might help us understand how life could form around stars far beyond our solar system. It could even unlock answers to questions about other habitable planets, other solar systems, and how the universe works on a fundamental level. Understanding our sun could teach us lessons about the origins of life. The implications of this mission are far-reaching. The probe's heat shield, for example, could one day be adapted for use in missions to other planets and moons, helping spacecraft survive extreme conditions on Mars or Venus. Now here's a fun thought: if you could ask the Parker Solar Probe any question, what would it be? Drop your questions in the comments below and let's get the conversation started. This mission is just the beginning. Who knows what incredible discoveries await us as the probe ventures further into the unknown. And then before we go, here are a few mind-blowing facts about the Parker Solar Probe. The Parker Solar Probe is the fastest human-made object to ever exist, traveling through space at an astonishing 430,000 miles per hour. It's the closest any spacecraft has ever been to the sun, breaking records every day as it ventures deeper into our solar system's heart. The Parker Solar Probe's heat shield can withstand temperatures up to 500 deg-1, 377 deg-CAC, enabling the spacecraft to operate in the sun's extreme conditions. The data it gathers could help protect satellites, astronauts, and even life on Earth by advancing our understanding of solar weather and space climate. This mission is rewriting the story of space exploration, and we can't wait to see where it takes us next. If you enjoyed this journey, don't forget to like, subscribe, and hit that bell for more cosmic updates. Until next time, keep looking up, and remember, the universe is full of mysteries just waiting to be uncovered.